Welcome back, and we're going to continue looking at that function that we saw in the video on increasing and decreasing. And so we came to this conclusion, right? So it's increasing on these intervals, decreasing on the others, and constant nowhere, right? Okay. Um, but it's kind of interesting if we look at those boundary places. So like when x was -1, right? We saw this behavior, and at 0 we saw this behavior, and at x is equal to 1 we saw that behavior, right? So we notice that each of those is like a peak or a valley, and so that notion in mathematics, we talk about that as having a relative or a local extreme value. Extrema is the plural of all that. Um, and so we would say we have a local min or a local max um, in each of these cases, but so specifically looking at a local maximum or relative, okay, those words are interchangeable. Use which one you like. I use local generally. So we say we have a local max if there is a small interval near a, so this is an x value. So we're thinking on an interval a, we look at it, and then if we think about the y value in there, right, it says such that f of a is bigger than, so here would be our y value, so we're saying f of a would be bigger than anything by it, right? So that everything else would be smaller than it, right? So that's why this definition is telling us, okay, we have a local max, okay? And similarly, local minimum would be the same idea. It's just instead of everything being smaller than it nearby, everything would be bigger than it nearby, right? So local min would occur in this sort of case. Okay, and one thing that I always like to stress in all this is a bit of language. So notice that when we talk about local mins and maxes, right, they are f of a values. So when we talk about what is the min or the max, oops, sorry, the min or max is a y value, and it occurs at an x value. Okay, so max or min is a y value that occurs at a specific x value. Okay, and then I mentioned, if we talk about multiple maximums and minimums rather than, adding an s on, we have to change the word entirely to maxima or minima. Okay, and then when we talk about all maxima and all minima, we call those extreme values, or if we don't want to use that language, again, we change the word to extrema. Okay, so then when we look at this thing, we want to identify the extrema, right, depicted in the picture. So we would say at this first place, I'll do kind of the origin first. So I'm going to say I'll have a local min of 0. Okay, that's again our y value at, and then sometimes I just write x is equal to 0, so I know that that is an x value, but normally in this spot we would say an x value. Okay, then I'm going to say local max, sorry, I reversed those, that's a maximum, my bad, and then local minimum of, okay, now this one, local minimum of, let's see, that would be -1, that's our y value at x is equal to -1. Okay, and then lastly, local min of -1 at x is equal to +1. That would capture this case. Okay, and so again, mins are looking like little valleys, maxes are looking like little hills. Okay, so in addition to local, okay, local is looking within a small region, we can talk about more global or what we call absolute extreme values. And that would just be, if we have an absolute maximum, that is the largest y value we can have in the entire graph. And similar for the absolute minimum, it would just be the smallest. Okay, so for instance, I could actually call like these 2 points down here, those could be absolute minima. Okay, you can actually have absolute and local minima at the same place, okay? An absolute can be a local. Um, Locals aren't always absolutes, though. It's a one-way implication, okay? Because, for instance, if I look at this one, if this is a local max, does that necessarily mean it's an absolute max? No, because I can find a y value that's bigger, okay? So again, absolute extreme value is the largest that we can possibly have. Let's look at this next example. Okay, we want to classify all extrema. So this is local and absolute extreme values that occur. Okay, and I'm just going to kind of look at it for a hot minute, and maybe you need to pause the video and look too. And what I see is I have this as a maximum. Okay, and I don't know about local and local or absolute yet. And then down here is a minimum, right? That's the bottom of a valley. Okay, and I don't know about absolute or local yet. Okay, let's talk about locals first. Okay, so at least in a small region, I can say that I have a local max of, oh gosh, what is this? Let's estimate that to be about 1.5 at, so that's the y value at x is equal to -1, okay? And down here, I can say I have a local minimum, because that's a valley, of, okay, and this looks to be what, -9, y value again, at x is equal to 3, okay? Now I'm wondering if I have any absolute. Do I have any largest y values or largest x values? Yeah, actually. Um, So the graph here doesn't exactly imply it, but this would continue down. So because it continues down forever, there's no absolute min. So I'm just going to say, I'm just going to make a comment, so no absolute min, okay? But I claim there is an absolute max, okay? What is the largest y value that I have? It is 1.5 of 1.5 at x is equal to -1. Okay, so these would be all the extreme values for this function. There is one point that we might need to think about a little bit more deeply, okay? And it's that endpoint. Endpoints are notoriously difficult to classify. And honestly, it depends on who's teaching you and what book they're using or if they wrote the book and whatnot. Endpoints have we have a hard time as mathematicians universally agreeing on whether you can have maxima or local maxima and minima at endpoints. Okay, and the reason is because when we talk about locals, right, they have to be in a region around it, and there's nothing on, in this case, nothing on the right side of this endpoint. Okay, and so for our course, I'm going to say we cannot, I'm going to just make this note, cannot have local local extrema at endpoints. Okay, you can have absolutes. Okay, if we had let this kept on going and it reached up there, that would be an absolute maximum for sure. Okay, but we just can't have local extrema at endpoints because we don't have anything on the other side of it. Okay, so be careful with endpoints, and if you have questions, always ask.